Now that we've got the road all fractured up, I want to focus on the frame, okay, on the other side. So maybe I'll drop a null here just to be nice and organized. Call this out metal, or frame, whatever, you know, same kind of thing. Okay, so what I want is to isolate, so some of these parts, see these kind of long pieces. If we take a look with this, turn on the visualization, that should work for me. I don't know why it's not. No. If I turn on the class, there we go, just visualize it like that. So these kind of long pieces, I want to be able to bend, you know, be kind of like bendy metal, and all these kind of small little pieces, probably these as well, I want to be rigid, you know, just a solid piece that can't bend. So they're going to be treated in a different way. The long pieces will have to be fractured and constraints generated between those, and those constraints need to not break as well. That's important, right? So, you know, small pieces need to be connected to everything else, and those constraints need to be able to be to break, whereas the long pieces, the big bendy metal pieces, need to be fractured down again, and for those constraints not to be broken. So, you know, we've got to kind of work all that out. So again, we're splitting up again. The way I'm going to do that is just by size. So smaller pieces will not be bendy metal, and bigger pieces will be, okay, essentially. So we need to measure. So we find a measure SOP, which is convenient for us. Okay, so we need to measure each piece, right? So here we're doing per element. Similar, we did it with the box earlier, to delete that, but we don't want to measure elements, right? We need to measure per piece. We can use the class attribute, but I think that might be problematic since, if you remember, the pieces at the end, they're not correct. So, and the name attribute at the moment, so we could just do it again, but what I'm going to do is just drop an assemble. Basically, doing this really is the same thing as dropping the connectivity SOP. Okay, it's just going to give us a name attribute for per connected piece here, right? And then in here, just come here and type name, and that should work fine for us, right? So now it's going to measure per piece here based on the name. Okay, so this is, if I come here now, this will generate a name attribute per piece. Now we visualize that. There we go. So you can see how that's working. So it's kind of similar to the class attribute. The colors are random, that's why they're changing. But the difference is the pieces at the end here are included, right? So if I change that over back to the class, you can see what's happening there. I could just use a connectivity SOP again. It doesn't really matter. It's just to give this some information in there. Okay, so that will measure everything for me. And now we drop a split, and let's take a look at this. Also a good idea to take a look at the values. So come into your primitives, look at that area. So you can see we're going to 17 down to super small values. So that's just to give you an idea of where to start, you know. So as per usual, at area is bigger or smaller, doesn't matter really. Let's try 1. We go, let's drop a null to what's discarded and kind of template that so we get an idea. Okay, take a look at that. So I'm just thinking, is there anything here? So these pieces I'd like to, yeah, definitely all these, I'd want them to be included, right? So we need to go smaller. Let's try 0.5. Almost. Let me just see if there are things here that I don't want to bend. So all of these, yeah, you can see they're going lengthways. I definitely want them to bend, right? I feel like we're getting closer now of 0.4. There, we just got a whole load more there just in that 0.1. see the difference of 0.4, and then if I connect it on this side, I don't think, yeah, so I'm just looking for really long pieces basically. These maybe you might want to do it, but depends on, you know, it all depends on your simulation. If you're focusing on one piece, like if there was an explosion on this point of the bridge only and it was bending here, but we're collapsing, you know, and our kind of point of view is something like this where, you know, the whole thing is collapsing, so you're not going to see these little bits bending. But if you have a different shot where you're really close up and you want some detail, then it might warrant a separate simulation where you've got much more detail here. Okay, so I'm going to leave it like that, but what I do see are these little thin wires. You see them? So we need to split these open, split them over by themselves. So I'm going to drop another split. Okay, and do this. Since we've got that name attribute, we can use that now. You could do it this way or use the name attribute, doesn't matter really. So I'm going to select both of these. You can see how what that's doing is that long piece, but they're just really thin. That's why the area is small. And take this one as well. Press enter. Okay, and then just merge that over onto this side like that. Okay, swap that round. There we go. So we got everything that's going to bend like metal there, just to kind of highlight that to us. Maybe I'll just give it some color. This is only, you know, it's not important, it's just as a guide, you know, as we're going. Okay, so just leave that in red there. Cool. We could group them as well. Bendy metal, and on this side rigid. I'm going to call this rigid metal. Okay, so what else? So if we come in here and if let's see, if I turn on the visualizer again there for the name attribute, that's fine. And let's see, I'm going to show you, no, sorry, on this side I want to show you, because it's more of a problem here, so particularly at the bottom here. So there you can see this piece is intersecting, is passing through this piece, and that's happening all the way back there. Okay, which is really, it's happening there again. There's lots of pieces kind of intersecting each other, which isn't great for for Boolean fractures, for bullet simulations. So to clean that up, what I'm going to do, what you can do, is drop a Boolean, okay, which typically what you would do is connect two things together and use one to cut the other. But what you can do is set a Boolean to union and then just connect the one input in, and you can see that's that's cooking that. And now once that's finished, if I come in here, you can see what that's done is kind of connected them together, right? Wherever they intersect, it has deleted what's on the inside, so there's no inside kind of geometry now, and unioned them together, joined them all together, right? So if we go turn that visualization off, press 9 and do 3D connectivity, we'll see that it's changed now. You can see all of this, which is this color, is one piece now. That's because it's been unioned by this, which is fine, you know. Well, it depends on what you want, but you know, that has connected a lot of this together, right? Or this whole piece down here, and a few of the bits on top will be connected together again. Okay, so let's turn that off. What we also need to do, can you see these blue patches there and there? That's because that's the back of a polygon. and that means this piece of geometry doesn't have any it's not watertight geometry, it's just flat, which is no good. We can't simulate with that, so I'm just going to delete these as they are, like that. Okay. Right, if we drop another connectivity sub here, actually no, we'll do that later. First of all, you know, as we're doing those booleans to clean things up, so this is kind of ready to go now. Well, with this part deleted, right? I'm going to use this to boolean this side now. We're kind of going back and forward, right? But hopefully you understand why, because there's still between these two, if we go back up here, you know, where we've got all the pieces together, there's other parts. So you can see there the small pieces and the big pieces, they're intersecting each other as well, right? And we've split it before we've kind of sorted that out. So I'm going to take care of that by doing it later on down here. So we're going to subtract here, press escape, make sure that doesn't crash. So I'm going to subtract from my rigid pieces using the big pieces. It's trying to do that. There we go. So connect that up there. It might take a while for that to cut, as it's, you know, quite heavy geometry. There we go. So I'm getting this funny red shade now from the color on the other side. I think it's copying over those red points. That doesn't matter, but that should help out our simulation a bit. Okay, so what else do we want to do? Let's we'll save that there for now, and then for the next part we'll look at fracturing the bendy geometry.